In this video, we begin on page 14 where we consider another example on how to compute confidence interval for the population proportion. In this example, we're told that the website is trying to increase registration for first-time visitors. And so it decides to expose 1% of these visitors to a new site design. Out of the 757 randomly sampled visitors over a month who saw the new design, 62 registered. Question 1. We have to check any conditions required for constructing a confidence interval. In this case, we'll need to check the condition of independence, which is satisfied because of the keyword that the sample was randomly drawn. The second one will be to compute the success, that is n times p. In this case, we have what? N, the sample size, is 757. P, the proportion in the population, is unknown, so we estimate that using p at, and that will be 62 out of 757. So that gives us 62, which is greater than 10. Then you have failure, which is n times 1 minus p at. That will be 757, 1 minus 62 out of 757. Let me write this clearly, 62. So that will give us 695, which is also greater than 10. So since all these conditions check out, we can use the normal distribution as a reasonable model for the sampling distribution of the sample proportion. We'd like to compute the standard error, however. We can do that in StatCrunch, and we can also do it by hand. But let's use StatCrunch since we have that software, which is really great. So let me go ahead. I am going to push this to the side and have what? And have StatCrunch here. Okay. So let's see what that looks like here. Okay. So I'm going to go again to stats. I'm going to go to population stats for one sample with summary. And the number of successes here is 62 out of 757. So 62 out of 757. And I'd like to construct a confidence interval. In particular, I would like a 90% confidence interval. So I'm making a jump ahead. And in the process, we can get the standard error too. I would like to store the results in the data table, show critical value, and compute. So I'm going to close out of this. I have my standard error right here, which says this is equal to, this is the square root of p at 1 minus p at all over n. This is the standard error, and it's 0.009966. 5403. And we're told that a 90% confidence interval should be constructed. We have the lower limit here and the upper limit here. So that will be equal to 0.065508. So 0.098296. This is the confidence interval, and we're to interpret it. So we'll say that based on the sample data collected and analyzed, we can be 90% confident that the actual but unknown value, unknown proportion of first-time visitors to this website, or first-time visitors who register under the new design, we're looking at the effect of that new design, lies between 0.066, which is approximately 6.6%, and 0.098, which is 9.8%. Okay, that helps us to conclude that question. All right, with that said, let us look at slightly a different concept. Sometimes when we want to estimate an unknown population parameter, we do not know what size sample we should select. Take for instance, a television sports what commentator wants to estimate the proportion of citizens who follow professional football and want to complete parts A through B. The question is, how many people should he what sample if he wants to what? To be within 3 percentage points. This is your margin of error with 95% confidence if he uses an estimate of 54% obtained from a previous poll. Whenever the sample size is unknown, we use this formula. So in this case, our n will be equal to p at 1 minus p at times z, the critical value, all over margin of error square. First, what are the ingredients we need here? We need p at, that's a point estimate. We have a prior estimate here given. So when a prior estimate is given, that is equal to our p at, that is 0.54. Then our z is our critical value if we want to capture 95%. What would that be? Let me show you how to get that. What you do is you go back to your start punch, go to start. We're going to use the normal go to start, go to calculators. We're going to use the normal distribution, and I want to capture a middle what? 95%. So let me reduce this. I want 95%. So I'm going to do that. I'm going to capture the middle 95% here. I'm going to put 95% here, which we did earlier. That should give me 1.96. Okay, so my critical value here is 1.96, and the given margin of error is 3%. So that is 3 over 100 or 0.03. So our computation begins. This will be 0.54, 0.54, 1 minus 0.54. Our z is 1.96 divided by margin of error is 3% all squared. On your calculator, you should get approximately 1060.2816. We're talking about human beings. So in this case, you must always round up. Always. Even if this is 2, you must round up. So you have 1061 citizens should be sampled. This is the number in the sample size that we should aim for if we want to achieve this goal. Okay. Another question here says, what sample size should be obtained if he still wants the 3 percentage points with 95% confidence but does not have a prior estimate? So this current question without the prior estimate is different from the previous one because the previous one has a prior estimate. So what do we do? In this case, whenever there is no prior estimate, we have a default value you must use. And that is P at equals 50/50, 0.50. So we're going to compute our sample size based on this assumption. So you have P at 1 minus P at, and then Z all over margin of error all squared. So that will be 0.50, 1 minus 0.50, and then 1.96 for the critical value divided by 3 percentage points all square. That would be equal to approximately 1067.111 rounded up. That would be 1068 citizens should be sampled. Should be sampled. All right, that brings us to the end of that topic.